have a question. Alexandra. Alexandra, do you know the difference between series and parallel? Alexandra, why are you ignoring me? Hello?
Oh my god, I'm so sorry. I couldn't hear you. My headphones are noise canceling.
So, what just happened here? She said her headphones were noise canceling. What exactly does that mean? Well, actually, there's a lot of physics behind what we just witnessed, right? And all of this physics lies in the physics of sound waves and how sound works, how it propagates, and how noise canceling and what we think of noise works in physics. Next is Katie to introduce what sound waves are and how they work.
Sound is all about vibration. To make a sound, something has to vibrate, whether that's the string of guitar, the voice box of a person, or in our case, music from a pair of headphones. Sound waves consist of vibrating particles, which knock into other particles and cause those particles to vibrate and knock into more particles, and so on and so forth, and that's how sound waves travel away from the source. We hear sounds because the vibrations in the air cause our eardrums to vibrate, and these vibrations are converted into nerve signals sent to our brains. So, when you imagine a sound wave, this is what you might think of.
So this is your regular sound wave.
Okay, so we just discussed how waves are the primary vehicle of sound. So sound travels in waves. Now, what does this have to do with anything else we're about to talk about? Well, what's really interesting is sound and sound waves are very different from solid objects, right? Meaning that sound waves can move through and with each other. They can be in the same place at the same time. If two sound waves have the same frequency and waveform, we call that being coherent, right? And this allows for everything else we could talk about. So let's look at the anatomy of a wave real quick. So we have a wave right here. When we talk about something like interference, which is going to be very important for noise canceling headphones, we want to look at the amplitude of a wave, which is its height. So when we have two waves, and you can draw two waves. Say we have two waves of similar amplitude and similar form. We call these waves in phase. So if these waves were occupying the same place at the same time, they are in phase, and what would happen is their two amplitudes would add on top of each other. They would stack. They would construct a bigger wave, which is what we call constructive interference.
So let's talk about how noise cancellation really works. So we just talked about constructive interference. Noise cancellation uses a process called destructive interference. So when the headphones hear something in their microphone, they produce a sound that cancels the sound wave coming in. So as you can see, being demonstrated, in this sound wave, at every point, the noise is being canceled. So if you add these waves up, you would get a straight line and zero sound. Alexandra, did you get all that? Destructive interference.